So this is lesson 3 of quantitative chemistry, and we're talking about RMM, relative molecular mass. So we're going to talk about atomic mass and molecular mass. We'll explain what those two things are, and I might also talk about formula mass. So they're all related concepts, but the first idea I want to get through to you is how do you make a cake? So that's sort of a very strange question, not to do with chemistry at all. Well, you know, you've got some flour and you've got some sugar and you've got some butter and some eggs, and you mix it all together and you shove it in the oven, right? And you leave it in there for a bit of time, and then it makes a cake, right? So that's not a great way to make a cake. To make a really good cake, you need to measure things out. So when you're doing baking, you're very used to the idea that you need to measure out 200 grams of this, 200 grams of that, 200 grams of that to add it all together. So the point is in the chemistry, to make some really good compounds and to not waste stuff, we also need to measure things out. But we measure things out in grams, but we also use another way of understanding how much we've measured things and how much we've measured out. So it's an idea called moles. But the whole idea is we need to understand the mass of particular chemicals, and that's what this whole lesson is about. So the objectives for this are to define atomic number and mass number, which should be some revision for most of you. You need to be able to look up the mass of an element from the periodic table, and then you need to calculate the relative formula mass of a compound. And then you, if you're working at a really high level, sorry if this is in front of it, explain why the relative formula mass of reactants equals the relative formula mass of products for a balanced equation. So this is linking all back to the last two lessons that we've done, so it all hangs together nicely. So for most of you, in fact for all of you, it should be a recap of a topic we did at the end of year 9. So we looked at the periodic table and we thought about what the letters and numbers on the periodic table meant. So I'll explain that to you again one more time. So the letters are the symbol, letters are the symbol for the particular element. So in this case, I've chosen P, which is phosphorus. But you've got all sorts of other symbols. You've got S for sulfur, you've got O for oxygen, you've got Na for sodium. So you should start to be a little bit familiar with those. But if you look at your periodic table, which is in your planner, you see that there's also some numbers up there. There's a big number and a small number. Okay, so some definitions you need to learn. The small number, we'll start with that one first, is the atomic number. Okay, so that's the key name for that. It's the atomic number, and it tells you the number of protons that that particular element has. Because all the periodic table is all of the elements arranged in terms of proton number, starting at 1 for hydrogen, 2 for helium, 3 for lithium, 4 for beryllium, keeps going all the way up to 113 or 118. It depends on which periodic table you look at these days. The number of protons also equals the number of electrons when you're drawing your circle diagrams. So you draw a circle diagram of how many electrons going around the outside. You should have done this in year 9. You may have recapped this so far. Certainly have done if you've been taught by me. So the number of electrons is the same as the number of protons. So for phosphorus, you've got 15 electrons, so which means that you've got 2 in the first shell, because that's the first level of the car park. You can only put 2 in. You've got 8 in the next shell. Okay. It means you've got 10 so far, which means you've got 5 left over to go in the outer shell. Okay, so remember you can put 8 in the next level of the car park and up to 8 in the one after that. Right, so the mass number is the other number on the periodic table. The mass number is the number of protons plus the number of neutrons. Okay, so what you can work out is that if the number of protons and neutrons is 31 equals protons plus neutrons, and 15 equals the number of protons. It's a little bit like solving simultaneous equations in maths. So you can substitute this into here. So 31 equals 15 plus n, which means that the number of neutrons is going to equal 16. And you should be familiar with that calculation now. So the total mass of phosphorus is 31, and you remember learning that only of your atomic particles, only the protons and neutrons have mass 1, and electrons' mass is nearly nothing. So that's why it's called the mass number. So you should be happy now to find the relative atomic mass of any monatomic element in the periodic table. So something like argon, you can look at it and you can look up that number, and the atomic number for argon, the atomic mass for argon will be, off the top of my head, it will be 40. So you can understand what the mass of an atom is, okay, so it's just 40 units, okay, so you don't need to worry about how many grams that is yet. Now, but you need to be able to calculate the mass for a particular molecule, okay, or what we call a relative formula mass. Okay, so chlorine gas, top thing in this table, doesn't hang around as Cl on its own, it hangs around as Cl2. So what you should know is that you've got 2 times Cl present, okay? I put that in the wrong column. There's only Cl and you've got 2 of them. Carbon dioxide has carbon and oxygen, types of element in it. It's got 1 times carbon, 2 times oxygen. Ethane has got carbon and hydrogen. Okay, it's 2 times carbon, 6 times hydrogen. I'm hoping this seems pretty straightforward now. Okay, so I'm hoping that you are familiar with the idea that the little numbers tell you how many of each types of element are present in that formula. Now we're going to use that to calculate the relative formula mass. So moving forward from that, I'm going to highlight for you here, this is water, H2O. Okay, so it's got 1 oxygen and it's got 2 hydrogens in it. So we want to find the relative formula mass for water. So we now look at our periodic table and we look up our oxygen. And on our periodic table it says 1680. Okay, so this tells us that the mass of an oxygen atom is 16. Okay, and we also need to look up our hydrogen. So our hydrogen is 1,1H. Now this tells us that the mass of our hydrogen, each hydrogen, is 1. If water is H2O, this then tells us that the mass of water is going to be 16 plus 1 plus 1. 16 is coming from the oxygen, 1 coming from one of the hydrogens, and the other coming from the other hydrogen. So, very straightforwardly, you can go through all of these different examples. Now, I'm going to pull out randomly, okay, I'll pull out this one to just explain a little bit more. So you've got H2SO4, which is sulfuric acid. This tells us that we've got 2 times hydrogen from this 2 here, plus 1 times sulfur, plus 4 times oxygen. Okay, so we've already learnt up the top here that our oxygens weigh, each oxygen weighs 16 and each hydrogen weighs 1. We do need to know what each sulfur weighs, which is 32, 16 sulfur. Okay, so our mass here is going to be 2 times 1 plus 1 times 32 plus 4 times 16, and that comes out at 98. So this is called calculating the relative formula mass, and when you are given any formula, you can just use your periodic table to add up the big numbers, multiply that by the number of each atom that is present to give you the relative formula mass. So why are we doing this? It seems a little bit weird. So I'm trying to link this all back to the last 2 lessons that we've been doing. So we're going to look at 2 particular elements. You've got 2412 Mg and 1680. So we've been looking at the magnesium plus oxygen calculation quite a lot so far. So we did our balanced symbol equation, said that 2 magnesiums plus 1 oxygen molecule gives 2 formulas of magnesium oxide. Right, so let's add up the masses of each of these things. So this is 2 magnesiums, so it's 2 times 24. 2 times 24. Okay. Now, what's the mass of the oxygen? Remember, we've got 2 oxygen atoms in here, so our mass of oxygen is going to be 2 times 16. Okay. And what we're going to make is 2 times 24 plus 16. So, work this through. 24 plus 16 is 40, so that's 80 on that side. 2 times 24 is 48. 2 times 16 is 32. So we've got 48 plus 32, which is equal 80, giving us 80. So this links back to our concept of conservation of mass, okay? Because we said that the mass of your reactants is the same as your total mass of your products. And we just proved it here. It actually comes from the mass of the atoms, because each magnesium atom weighs 24. We've got 2 of them, 48. The oxygen, weighing 32, has to make 2 formula units of MgO, each of which weighs 40.